Okay, page 118, number 7. Okay, properties of logarithms. Log x plus log 2 minus log 4. Here, this would be the product property. You can write this as 1 log and multiply the 2 and the x. Then this subtraction is the quotient property. So I could put 4 underneath. When you subtract the same logs, it leads to a quotient if you want to condense. So this would actually go down to log 1/2 x. It doesn't say you have to do it, but you should know how to do that. So the plus sign is the product property. The minus sign is the quotient property. So that's condensing. Okay, next one. 119, 3 through 5, and 7. Can't believe I gave this to you. What multiplies to 121 and adds to 22? 11 and 11. X to the third minus 125. That is a difference of cubes. So it's a binomial, a trinomial. You memorize the signs, minus, plus, plus. And it's the cube roots. And then you square the first one, x squared, multiply them together, and square the 5. Perfect cubes. Number 5. It's 3 through 5 and 7. Number 5. Oop. Alright, so we're gonna, it's 4 terms. So we're gonna factor using the grouping method. We'll look at 2 at a time. Take a 3x out, and you have x plus, take a 3x squared out, and you have x plus 8. And then the other 2, the GCF is 2, x plus 8. The parentheses match. 3x squared plus 2, x plus 8. It's the grouping method. And then number 7. All right, we have an unknown exponent. We'll have to use logarithms. All right, so we'll have to write log on both sides. And then we can use the power property to move the x to the front. And then we're going to divide both sides to get x alone. So now x is alone. It's log 15 over log 5 divided out. And x is approximately 1.683, which makes sense. 5 squared is 25, so it can't be as high as 2 when you plug it into the original. All right, moving on, page 121, number 1. Oh, I was working on this in class today. Let's take a look. Here it is. 121, number 1. So what I decided to do is to rewrite this with a common denominator. So I had to put this 3 over 1 and make a common denominator, which would have been x minus 1 times x minus, yeah. So I FOILed this, and that is x squared plus 1x plus 1x plus 1, or x squared plus 2x plus 1. And then I realized that would be the common denominator. So that needs to be multiplied to the top and bottom. So this would be 2 minus 3x squared minus 2x minus 3, because you have to distribute this negative 3 in, over x squared plus 2x plus 1, and that will move to negative 3x squared minus 2x minus 1 all over x plus 1 squared. So the first step is to solve the bottom. So that gives us negative 1. That's an asymptote. So here's a dashed line at x equals negative 1. Then you have to solve the top. So I'm going to see if it factors real quick. If I take a negative 1 out, 3x squared plus 2x plus 1 multiplies to 3 and adds to 2. The top does not factor, so there's none. And then step 3 in creating a graph is to compare the degree. And the top is squared and the bottom is squared. So the line A over B is the asymptote. So that's negative 3 over 1 is the other asymptote. And so I finished graphing that. And then after that, you make a table. So negative 1 when you plug in is undefined. So I just did 2 points to the left and 2 points to the right. So far I got negative 2.5. And I'm going to plug into the original equation, not the common denominator equation. So that's 2 minus 3 is negative 1. And I'll do that again. Negative 1. So 1/2 minus 3 is negative 2.5. So I do see symmetry here. So let's plot our points. So negative 3, 1, 2, 3. Negative 2.5, 1, 2, 3, 1, 2. Boop. Negative 2, negative 1. 0, negative 1. And 1, negative 2.5. So, remember to start your pencil near a dash line, move through the points, and near a dash line. Missed it. And this is this graph. So might as well say the domain is everything besides negative 1. And the range is y is greater than negative 3. So that was a really good review of the steps. As a reminder, I would provide you with a handout with these steps. All right, that's done. All right, number 9. So remember, you start with solving the bottom. So you need to factor it. And we have 2 vertical asymptotes. So those will be dashed line. And then we'll solve the top. And that will tell us that there are no horizontal asymptotes, and that's because there's no x up there. And then we will compare degree. And the top is less than the bottom. So there are no vertical asymptotes or horizontal asymptotes. So looking at the graph, it looks like there's one. Y equals 0 will be a horizontal asymptote. So I can already begin the graph. So we have negative 3 and positive 1. That's exactly where the other ones. No. Okay. And 0. So we need a pretty good size table here. We're going to put in negative 3 and see that that's undefined. And let's do negative 2, 0, 1 is undefined. So I'll do 2 to the far left and 2 to the far right. Wish I had a calculator right now. Okay, so 3 over 25 minus 10 minus 3. 3 over 12. A positive number. And then it would be 3 over 16 minus 8 minus 3. So that's 3/5, a little bit bigger number. 3 over 4 minus 4 minus 3. Ooh, -1, negative number. And then, 3 over 0 plus 0 minus 3. -1 again? Okay. Okay. 3 over 4 plus 4 minus 3. What? Three-fifths. I'm seeing symmetry. And then 3 over 9 plus 6 minus 3. 15 minus 3. 3 over 12. Okay. I like it. So let's plot these points. -5 and 1/4. -5 and 1/4 positive. -4 and 3/5. Really bigger. -2 and -1. 0, -1. 2 and 3/5. 3 and 1/4. Yeah. Alright, start near an asymptote, move through the points, end near an asymptote. There it is. There's your domain and range. Let's move on. 123, number 2. Okay. Nope, solve the bottom first. Then solve the top. Shoot, that's an x-intercept. So the top is always x-intercepts. And then next we compare degree. And this time they both are a power of 1, so the top equals the bottom. So a over b is the asymptote. In this case, y equals 1 is the horizontal asymptote.